and vertically. It is a very important point used in jet engines. Let me discuss the example of this. Example, this is a Russian Su-37 which incorporates thrust vectoring. This is a thrust vectoring system. Here we change the direction of the flue gases exhaust gas or exhaust gases. By this we have an thrust, so the plane which is use the turbo vector system or thrust vector system can lift off easily or lift down easily. Here are some review questions. Let me discuss one by one. Which part of the jet engine converts the energy of the expanding exhaust gases to the mechanical energy? Second review question is, list 3 additional systems needed for operation of a jet turbine engine. Which are the 3 additional systems? Student can write or learn from the previous slides. What is the differences between a radial flow or an axial flow jet engines? And the last, how does an afterburn works? It is very important. These are some examples of the aircraft engine selection. Which engine is best for the job? This one is used on the earth. This one is used at very high altitude, and this one is used at medium altitude. Let me have discuss objectives. After this lesson, students should able to list possible application of each type of a jet engine and also advantages and disadvantages of each type of the jet engine. Now let me discuss one by one. Next point is selection criteria. When selecting an engine of a particular vehicle, the following criteria must be evaluated. First one is very important, price. Second, designated speed of the vehicle operation which we required. Third is designated altitude of the vehicle operation. In the previous slide we discussed 2 planes which is used at medium altitude as well as other one is at higher altitude. Next is range, fuel efficiency, very important, and the last, maintenance and the durability. Now let me discuss naturally aspirated piston engines. The first is, these are relatively inexpensive as compared to turboshaft engines or turbojet engines. The piston engines are very inexpensive. Second is limited power at high altitude due to the lower air density. This is a major drawback of these engines. These cannot produce higher power at higher altitude. Next is speed is limited due to the propeller inefficiencies at high speed more than 500 miles per hour. Let me discuss the next slide. Supercharged or turbocharged piston engine. This is the advancement in the piston engines. First, able to operate the higher altitude than a naturally aspirated engine. By the modification in the older engines, if we introduce supercharged or turbocharged engine, we can increase the operation of the engine at higher altitudes. Turbocharging and supercharging increases the density of the air entering in the engine, which is the major drawback of the older engine. Next is still somewhat is limited by the altitude, but speed is still limited due to the propeller efficiencies at high speed is very less than the 500 miles per hour. Now let me discuss the turbojet engines. Uh, Turbojet engines has no reciprocating parts. Thrust is not greatly affected by the altitude, very important. Relatively small frontal area is desirable for the high speed, which is also known as supersonic speed. Relatively high speeds, low mass to exhaust gases makes the turbojet somewhat inefficient. And the last is high speed exhaust is extremely noisy. Noisy, uh, this is the major drawback of the turbojet engine. Also, it is we have discussed in the previous slides. These are some advantages and the disadvantages of the jet engine. Let me review fast. Having no reciprocating engine, this is the advantage of the turbojet. Thrust is not greatly affected by the altitude, it is also advantages. Relatively small frontal area is desirable for the high speed, it is also an advantages. Relatively high speed, low mass to exhaust gases makes the turbojet somewhat inefficient, and it is noisy. These are the some disadvantages. Turbofan. As compared to the turbojet engines, turbofan are somewhat more efficient than the turbojet engine. First, let me discuss the point. Because the large inlet fan moves a larger volume of air at lower velocity, the turbofan is more efficient than the turbojet engine. The second is because of the lower exhaust speeds, the noisy level is greatly reduced. This is the major advantage of the turbofan engine over the turbojet engine. Next is the large inlet fan creates a large frontal area, which negatively affects drag at high speed, essentially in the supersonic speeds. Most effective at speeds below supersonic. And next is, however, modern fighters are now using state-of-the-art turbofans for supersonic flights. These are some advantages and disadvantages of a turbofan over the turbojet engines. Now let me discuss the turbopropeller. Turbopropellers are more efficient at lower speeds and second one is produce greater power than a comparable piston engine with less weight, less noise and less maintenance. More expensive than the piston engine, but it is a basic disadvantage of turbopropeller engine over the piston engine is these are more expensive. And next is must use a gearbox to reduce the high turboshaft RPMs down to the propeller RPMs. Because the turbopropeller rotates at a very high RPM, So we have to use a gear reduction box, which is generally known as a differential in the automobiles. We have to use gearbox to reduce the RPM, which is uh, required RPM or the desirable RPM in the turbo propeller engines. These are again, these two pictures also we have discussed. Apache on the right hand side and the tank on the left hand side. These turboshaft engine are used in turbopropeller, helicopters and land-based applications. Land-based application means tank we are using. The next is must use a gearbox to reduce RPM, but the major problem is we have to use the gearbox, so the weight is increased in these engines. M1 Abrams tank, which having 1500 horsepower turboshaft engine. Now let me discuss Pulsejet engine. These are relatively inexpensive because as we discussed in the previous slides, these contains no compressor, no some other parts, and also they are light in weight due to absence of these parts, and this does not have ability to produce thrust at a low speed, and these Pulsejet having a simple construction. And here is the basic diagram of the Pulsejet engines. Now come to the Ramjet engine. Ramjet engine only used for extremely high speeds application. This is mostly used by the military or in the NASA. This is the X-15 Ramjet engine, and used by the NASA is SR-71. These Ramjet produces thrust at a high speed and having no moving parts. Let discuss review questions. First question is which type of engine are least practical at a high RPM? The second review question is which type of engine are least practical at supersonic speeds? Next question is which type of engine could be used to produce an electrical generator? And the last review question is why is a turbofan more efficient than a turbojet engine? This is the last slide in this presentation or the EduSet lecture. These are the basic questions which can be reviewed by the students as well as my colleagues. Which type of the engine are less practical at the high speed or high RPM? Which type of the engine are least practical at supersonic speeds? Which type of engine could be used the power and electrical generator? And the last is why is a turbofan more efficient than a turbojet engine? So if we review these questions, we can understand the phenomena of jet propulsion engine, types of jet engines, and their application in the different fields. So I am very thankful to all of the listeners, especially my dear students and my dear colleagues. Thank you so much.